Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aini Bishrosan, MA18164. So today I will present about introduction. So basically, in my introductions, it have two figures, which is one is basic coordinates and one is evaluator. So what is basic coordinate? Basic coordinates, which is the equation governing an aircraft motions, are a complex set of non-linear couple different equations. So they can be decoupled and linearized into longitude and lateral equations under the certain assumptions. So for the evaluator, the goal of the evaluator is to change the diffractions angle is the component that cause it to change. So second is to obtain transfer functions of time domain, which is will be used to analyze the response. So third is evaluator operates in a pair, which is when the right evaluator move up and the left evaluator move up as well. So this is equation that we use. So first, this is the equation of motion that the aircraft, and this is our transfer function equations. So basically, these transfer functions include the evaluating each force component and its effects on aircraft. So this is our objective. First, to design with Excel in Matlab Simulate, and second is to learn how to interface the hardware and software, and third is to create a linear controller for the system and truly analyze it, and also make a comparative between different controllers, and the lastly is to write report that include a brief description of aircraft pitch angle system as well as different types of controllers. So that's all from me. Thank you.
Assalamualaikum and hi, my name is Nohalimatul Manap. My metric number is MA18077. Today I will explain about result and discussion. Design criteria. We assume that overshoot less than 10%, rise time less than 2 seconds, settling time less than 10 seconds, steady state error less than 2%. So this is our system equation, modeling equation, Laplace transform equation. These values are taken from the data from one of Boeing commercial aircraft. Next is transfer function. We get equation transfer function. This is Simulink 5 for the system using Matlab Simulink. For open loop system based on transfer function, the open loop system is the point-to-point open loop transfer function is the response obtained by opening the loop at the specific location, injection signal at those location and measuring the return signal at the same time at the same location. This is our coding. After we running the coding, we get graph open loop step response. One of the most used technique to analyze the stability in time domain is simply apply a step input. So for open loop step response is obviously unstable. Its output increase unbound with step input and the pole is at the origin. That's all from me. Thank you.
Hi, I'm Nuraina and I'm going to continue for loop locus and closed loop system. This is the continuous MATLAB code for loop locus and this is the plotted graph. At the graph we can see there is 3 poles and 1 zero. However, only one pole managed to find 0 and the other 2 poles will go to the infinity. There is also branch in this root locus graph. For closed-loop system, this is the Simulink transfer function where there is setup block, summing junction block, transfer function, and scope as the output with the feedback connection. So, this is the coding for closed-loop system. On the right, there is a graph with rise time 1.8 second. Settling time 37 seconds. However, the system is still unstable with final amplitude 0.2 radian. Because of that, this system needs to be upgraded to stabilize it. So, we will go to the next presenter.
Hi, Assalamualaikum. My name is Nur Syafiqah binti Nur Sofian and my matrix number is MA18034 and I will continue the presentation with the topics of PID Controller. So P stands for the proportional gain and the symbol is KP, and I stands for the integral gain and the symbol is KI, while D stands for the derivative gain and the symbol is KD. So next, as we can see, this is a table of the PID characteristics. And if we change the value of KP or KI and KD, so the value that also change is the rise time, overshoot, settling time, and the steady state error. So PID will occur in a closed loop system, and the variable that being controlled is the output of the controller and the input of the plant. And PID, the position of the PID is in the section of the controller. And now for this figure, it shows the closed loop PID system for our project that have been built in the Simulink. So for our project, in order to improve the system, we change the value of KP and KD, while for KI, since it's only give the small effect or small change, so we decide to make it constant. And for this first graph, we use the value of KP and KD is equal to 10. So as we can see, there is almost 0% of overshoot, however, the settling time is quite high. So for the second graph, we increase the value of KP, which is equal to 20. However, for KD, we still remain the same. And as we can see, the settling time have become lower. However, there is an overshoot and steady state error that is occur. And for the third outcome, we increase the value of KP and KD, which KP is equal to 50 and KD is equal to 30. And as a result, we managed to lower the settling time and we managed to reduce the overshoot and the steady state error. And we can conclude that when we increase the amount of the KP and KD, we manage to improve the stability of the system. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Karun Adhani binti Karun Nizam. My matrix ID is MA18102. I will present the conclusion part of this project. So as a conclusion, we learn how to calculate the transfer function using the Matlab software. And our project is related to the pitch angle of an aircraft. So we conclude that the elevator deflection is the input while pitch angle is the output. From the transfer function we use them for time response, root locus, and to find the stability of the system. To analyze the stability in time domain of the aircraft, we applied the step input to the initial open loop system. The parameters that we analyzed to analyze the stability are the overshoot, rise time, settling time, and the steady state. Then, using the Matlab coding for open loop system, we found that the system is unstable. So, to stabilize the system, we use the root locus to show us the manner where the open loop poles and zeros should be changed. Then, by using Matlab coding for closed loop system, we also found that the system is still unstable. Then, hence, we use PID controller to obtain the system stability by increasing and decreasing the KP, KI, and KD for each parameters that I've been said from the slide before. So that's all from me. Thank you for listening.